Compartmental analysis. So two occupations I can think of that may use this are civil engineers and building contractors. They may deal with this when they are dealing with gases and ventilation is required, because you would want to take out more gases than you're making pretty much. So here are some basic equations and their explanations. The main equation is the first one right here. D of A T over dt equals the rate in minus the rate out. And so here's the problem we'll also be doing, is problem number 1 from the homework. A brine solution of salt flows at a constant rate of 8 liters per minute into a large tank that is initially held 100 liters of brine solution, in which was dissolved 0.25 kilograms of salt. The solution inside the tank is kept well stirred and flows out of the tank at the same rate. If the concentration of salt in the brine entering the tank is 0.05 kilograms per liter, determine the mass of salt in the tank after t minutes. And for part 2, when will the concentration of salt in the tank reach 0.02 kilograms per liter? So the first thing we probably want to do is pick out some information from the question. The rate in and the rate out is the same at 8 liters per minute. The total volume of the tank is 100 liters. The concentration that's going in is 0.05 kilograms per liter. And the current salt inside of the tank is 0.25 kilograms. So we can find something else. We can find the rate of the salt that's going in by plugging in the rate in, which is at 8 liters per minute, times the concentration that's also going in, that is 0.05 kilograms per liter. And that gets us a rate of salt going in of 0.04 kilograms per minute. And we will need that for the remaining of the problem. So when solving this, you basically want to follow the steps down here as you keep going down. That 0.04 will eventually turn to 40 right here in this part right here. You'll just keep following the steps down here. Once you get to about right here, you will integrate these two parts right here. You integrate both sides, you'll get this right here. And when you get here, you pretty much want to get the C by itself. So that leads us down over here where C will equal ln negative 4.75. And once you figure C out, you want to plug that back into this equation up here. And that's when we're going to solve for A of t. And for the A of t, we got 5 minus 4.75 e to the negative 0.08 t. And that will be your answer for part A right there. And now for part B, which is pretty much part 2, it's asking us for the concentration of the salt reach. Well, when would the concentration of the salt reach 0.02 kilograms per liter? Now, this is the basic equation right here. Concentration of salt equals A of t over 100. You'll pretty much just plug in this part right here, 0.02 for the concentration of salt, and you plug in your A of t right here. And we're pretty much trying to find out is what does t equal. So you do, first of all, you'll subtract 5 from both sides. You'll get negative 3 equals negative 4.75 e to negative 0.08 t. And then you divide the negative 4.75 to get this value. And then we have to get rid of the e, so we do the ln 3 over 4.75 equals negative 0.08 t. You just divide that negative 0.08 over, and you'll get this right here, this equation, which is t equals ln 3 4.75 over negative 0.08. And then you should get your final answer, and you want to make sure you round it up to the hundredths place. And this right here is pretty much what the solution would look like.